Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience education. So, I am going to discuss about some of the topics of a fluid properties. So, topic that I am going to cover is your speed of a flux, that is Torricelli's law, and application of Bernoulli's theorem. What are the application of Bernoulli's theorem? Dynamic lift, ball moving with the spin, Magnus effect, aerofoil, lift of a aircraft wing. So from figure you can understood that what we are talking about Torricelli's law. So first of all, I will go to discuss about this law. So see here. So before going to discuss about this law, so try to understand here what I am talking about. See here. Let us consider there is a water. Okay, there is a water, right? And water at a height h it is filled full of water. Okay, the cylinder is full of water, and can we make a hole at this point? So at a point C we have made a hole which is at a depth of h, it is at a depth of h, and you know that the above there is an atmospheric pressure. Here also there is an atmospheric pressure outside. Okay, now if the liquid is filled in a vessel up to the height h and the hole is made at a depth, so velocity of water is coming out of the sea. So definitely water will come out with the velocity b. So velocity at a point A is velocity at a point A is 0. Yes, definitely at the same level. See here, velocity at the point A is 0, but velocity at a point is velocity BC, right? So we can understood from this figure. Now we want the velocity of water. So let us use the Bernoulli's theorem. So as per Bernoulli's theorem, pressure energy, kinetic energy, as well as potential energy will remain constant. Now if we talk about at A, energy at A as well as B is C, both are same. Now if I will talk about energy at A, so pressure energy P atmospheric pressure by rho plus zero velocity is since this fluid is static at a point A, so this is your 0 square by 2 plus gh. This is your potential energy, right? Because it is due to gh height. Now when we come about when we discuss about the point energy at a C, so there is a pressure energy, that is P atmospheric by rho plus v square by 2. It has some kinetic energy, and because it is moving with the velocity v, and you know that there is no height of the liquid at all, so we can write it 0. So we can cut this and this. So finally we will get gh is equal to v square. So v square is equal to 2gh, and this v is equal to root under 2gh. Okay, now if you have studied kinematics of an object or when an object's motion, so equation is same as that of freely falling ball. When a ball is freely falling with the height h, so velocity at a height h can be written is equal to v equal to root 2 and 2gh. Okay, so here we can say that the height at a height h and is known as Torricelli's laws. So this Torricelli has given same thing, that whenever we want a velocity, so velocity will be equal to root under 2g into h. H is the height above the height or at that point above the height of the liquid above that point. Okay, so same thing. It is very similar to that of the freely falling body. Now I am discussing about the dynamic lifts. What is dynamic lifts? So dynamic lift is the force that on a body such that an aeroplane wing or hydrofoil or spinning ball, see spinning ball. See here what actually dynamic lift is, that when an object is moving, so it will try to move upward direction or downward direction. So these type of things are known as dynamic lift. Okay. So I will discuss one by one how aeroplane is flying above the sky, above the ground in the sky, and how you are using a Bernoulli's theorem here. So Bernoulli's equation, just we have studied Bernoulli's equation. If we don't want to discuss this Bernoulli's, so you know that pressure energy by rho plus v square by 2g plus gh is equal to, if it is your pressure energy v1 square plus 2g plus gh1, so this will be equal to pressure at a 2 plus v2 square by 2 and plus g into h2. Now if I am considering any object is moving, so what will happen? See here, when it will move, so what will happen? There is a movement, so there is an air, and air is moving up and down as well as. When in figure you can see here in figure, I'm just showing you in the slide. So this figure, what they are telling in figure, from here you can understand that there are two types of flow, that is your lower part flow and upper part flow. So see here, in upper part its bend is more, so due to that bend, so what happened, air molecules come closer and coming very fast, but at below, so it is very slow. So can we write here that velocity above is more, velocity above is more, and velocity below aerosol is less. So there is a change in a velocity. But if you talk about the energy, so energy coming here will be there. It will be constant. Either it is an upward part as well as downward part. So when we talk about energy, so energy will remain same. So what we need to cut here. See here, GH1, GH2 will cut because they both are at the same height. So here we can see that pressure and velocity, as well as pressure P2 and velocity P2. Now if velocity will, see here, the addition of these two things should be constant. Now if you want to, if there is a change in a velocity, suppose velocity V1 is increasing, so what will happen? Pressure will decrease, right? If velocity will decrease, then pressure will increase. Now from figure, downward movement velocity is very less. So velocity is less, it means pressure is high. And above, what happened? Velocity is more, but pressure is less. So what is happening? So above there is a low pressure zone, and below there is a high pressure zone. And due to this, what happened? It will try to lift the object. So this is the basic principle. See here. See again, I am telling you. Above what is there? Velocity of air is more, and due to this, what will happen? Pressure will be less. And below there is velocity is less, so what will happen? Due to this, pressure will increase. So here there is a pressure difference. Lower part has high pressure and upper part has low pressure. So if there is a high pressure and low pressure, so what will happen? This will try to lift the object. So similarly, what happened in aeroplane also? Aeroplane also, what happened? Aeroplane also, if aeroplane is moving with a very high speed, so same thing is happening. And due to this, what happened? Aeroplane get lifts off. Okay, so in this way, Bernoulli's application, this is the Bernoulli's theorem. By the use of Bernoulli's theorem, you can understand that how aeroplane is being lifted, and by that is the practical application at all. Okay, one more important thing is your Magnus effect. If I am talking about Magnus effect, see here, Magnus. What is Magnus effect? See, a ball is spinning like this. So can you tell me? So see here, air is coming with the velocity v, and ball is moving in this direction. So what will happen? Below, velocity will increase, yes or no? And above, what will happen? It is opposing the air motion, so velocity will decrease. So if velocity will decrease, then what will happen? Pressure will increase. And here velocity is increasing means what? Pressure will decrease. So there is low pressure. So due to low pressure, so what will happen? Ball will try to move downward. Okay, so this is a very useful application of the spinning of ball. So a cricketer want to deviate a ball, so what he will do? He will spin the ball, and due to spinning effect, what happens? So it will try to deviate at all. Got it? And this process is known as Magnus. This effect is known as Magnus effect. So see here, this Magnus effect. See here, here what is happening? Velocity is here. Velocity is very high. Above velocity is high, so pressure is less. And below what will happen? Velocity is less, so pressure will be high. So when pressure will be high, what will happen? It will try to lift. Got it? So ball will try to lift it. So this is a Magnus effect. Same thing, aerofoil of the aeroplane. What happening? See here, above velocity is very high, but pressure is low. Below velocity is less, so pressure will be high. So due to this, there will be a lifting condition. So in this way, all the aerodynamics works. Okay, so if you want to lift with the movement, So this is the Bernoulli's application. Also, one thing I want to more clear out more. One thing I have seen, I've seen mostly in a train. What happened? Train is coming. So let us Train is moving. Okay, train nowadays. Train is moving, right? Train bogies, engines are all are being with a very fast pace. But the air, so air there is also same Bernoulli's application. There is Bernoulli's application. So velocity is very high. So what will happen? Pressure will reduce. So when pressure will reduce, so what happen? Atmospheric pressure will be very high, but inside this or side by side this pressure is low. So what will happen if any person is beside the train? What will happen? High pressure will try to push the person, and person may get an injury. So that's why we need to be aware that we should must keep our body far away from the train movement. So this is the most important example. Okay, so I hope you have understood these things. So for further video, please be connected with our channel. Thank you for watching my videos. Thank you.